Good morning everyone. Hello my dear students. Welcome to IMS GATE Academy. I hope you all are preparing well for the GATE exam. Myself Vipin Mishra, the lead mentor at IMS GATE Academy, and I welcome you all in this GATE Score Booster series of IMS GATE Academy. Now as the exam is inching closer and closer day by day, now you must be wondering what all are the important topics, formulas and questions that you should prepare in order to give a boost to your preparation. Especially when it comes to subjects like power electronics. The job is very difficult because the subject is filled with so many formulas and derivations, isn't it? But if you are really wondering with these questions, just join these two sessions today and tomorrow, and power electronic will no more be a nightmare for you. You will enjoy power electronics. Okay. So when it comes to subjects like power electronic, there are basically 4 chapters that we have. The first one is power semiconductor devices. The second one is DC to DC converters. Third one is rectifier, and the fourth one is inverter. So I am going to take 2 sessions. One is today that you are attending right now, and the second one will be on tomorrow. So today I will be discussing the first 2 chapters, power semiconductor devices and DC to DC converter. And tomorrow it will be the turn for rectifiers and inverters. Now as the purpose is to give a boost to your score and to make you comfortable in this subject, so what we will be doing here is we will be practicing the question, and together I will tell you how you can approach for a particular question. Good morning Nilmesh. Very good morning. And how you can approach for a particular question. So the purpose will be to make you approachable for a particular question. Okay. Instead of remembering the formula, writing the derivation, how you can get to a particular expression required to solve the question. So that will be the purpose of this series. Okay. So let's get started with first chapter, which is power semiconductor devices. So if we talk about power semiconductor devices, there are basically 3 important topics there are in this chapter. First one is the power semiconductor devices, in which we have to have the knowledge of so many devices and when to use a particular devices. Then there is an important topic which is called as switch realization or switching power law. So constantly there has been questions from switch realization and switching power losses. Then the final topic is commutation circuit. It is also giving question regularly. Good morning Divya. Okay, so these are the content of the first chapter. And what is the weightage of this particular chapter? So it can give you marks around 1 or 2. Okay, so there might be 1 question, there might be 2 questions from this chapter that you may see in the upcoming GATE exam. Okay, so let's get started with the very first question. Yes, and that is from switch realization. So this is the question. Let me read it out. What has been given in this question is, which of the following switch will have VI characteristic as shown in the figure? So this is the switch realization given to us, and the switch is blocking positive voltage and it is carrying positive current when it is on. So we are getting the switch realization in first quadrant. Now these are the option A, and this is the option B, option C and option D, and we have to choose which of the following switch, okay, is having the same switch realization as we have been given in this particular question. Okay, there might be more than 1 option correct as well. Okay, Nilmesh and Divya, you are saying B. There might be more than 1 options correct as well. So before checking all the options, don't give any answer. Okay. Yes, B is right, absolutely correct. So let me give you time. You can take your time and then you can decide which is going to be the correct answer here. So I am giving you 2 minutes for it. Now Nilmesh is saying D is also correct. Very good. So before actually checking what can be the correct answer, don't give any answer. Okay, Nilmesh? Yes, B and D. There might be more than one options which may be correct here. Take your time. Don't be in a hurry. Okay. In option number A, we have BJT, in which we are having a parallel diode connected to it. In option number C, we are having MOSFET. Option number B is IGBT, and option number D is having option number A plus a diode connected as well in series. Okay. So the answers that I am getting from Nilmesh is B and D. This and this. Divya is saying B. What about others? Take your time. Last 10 seconds. So Nilmesh, would you like to change your option? Divya? Okay. So let us solve this question. So how to approach for these type of questions? If you have to realize a particular switch combination, what you have to do? You have to look forward for the voltage that the switch will block when it is reverse bias, okay, or when it is in off condition, not reverse bias. We have to look forward the voltage that the switch will block during its off condition, and we have to look forward for the current that the switch, very good, and we have to look forward for the current that the switch will be conducting when it is on. Okay, so what we have to look for? We have to look forward for the voltage blocked during off state, okay, and the current during on state. So you have to look for the voltage blocked during the off state and the current conducted by the switch during the on state. Okay. So for IGBT we know that the switch realization will be like this. If this is voltage, this is current. So IGBT, it will block positive voltage and it will carry positive current. Okay, same as BJT. When it comes to MOSFET, you know that MOSFET can carry current in both the direction, isn't it? It will carry both type of current, the positive and the negative, and it will block positive voltage. Okay. So this characteristic is exactly matching what we have to realize, but this is not matching. So option B is a correct option. Yes, it is correct. Now we have to look for option A and option D as well. So let us realize the switch number A. So what do we have in switch number A? So if we talk about the switch number A, in that we are having a BJT and an anti-parallel diode. Okay. We are having a BJT and an anti-parallel diode like this. So what is the switch realization of BJT? So if we talk about BJT, the switch realization of BJT and IGBT is almost similar. Okay, what type of switch realization it will give you? If this is the voltage and this is the current, it will give you operation in first quadrant. It will block the positive voltage and it will carry current in positive direction. Okay. So this is related to BJT. Now for diode. So if I talk about diode, how we have connected the diode in this manner. Okay. And this is how it will be handling the voltage. Current, if it will flow in this direction. So what will be the switch realization of this kind of diode? It will block positive voltage, but it will carry current in negative direction. Okay. Now if you see BJT and diode, they are connected in parallel. So when two switches are connected in parallel, or when any two elements are connected in parallel in electrical concepts, what do you know? The voltage has to be same, but the current has to be different, isn't it? So if we take the parallel combination of these two switches, we have to take the same voltage but different current. Then what we will get? So we have to take the same voltage and we have to take different current. So voltage we have to take same. So positive and positive. So same voltage will be the positive voltage, but current can be different. So here you have negative, here you have positive. So you will take both currents like this. So you are getting operation in first and fourth quadrant, but we want to have only in first quadrant. So this cannot be a correct option, isn't it? So option A is wrong. Okay. Option C is a wrong answer. Option A is a wrong answer. Now, what about option D? Okay. So in option D, you can see this much of switch we have already realized in option A. Now we have to connect a series diode only. Okay. So let us connect a series diode and see what we will get. So if we talk about option number D, in which what we are having? Now, apart from this, we have connected a series diode here as well. Okay. So if you see this much of combination, you have already realized in option A. So this is nothing but option A plus a series diode. Isn't it? Option A plus a series diode. So if you have a diode connected like this, where it is handling this voltage and current, then what could be the possible switch realization? It will block negative voltage, isn't it? And it will carry positive current. So it will block negative voltage and it will carry positive current. So this will be the switch realization of this diode. Now what we have obtained for this particular combination, which we have already realized. So for this combination, what we are getting? For this combination, just now we have realized this is carrying positive, this is blocking positive voltage, but it is carrying both type of current. Okay. Now this combination which has this switch realization and this diode which is having this switch realization are connected in series. So what do we have in series? In series there will be same current but different voltages, isn't it? This is what we have in electrical engineering. So if we realize this both in series, what we will be getting? This is V, this is I. So voltage we have to take different, but current has to be the same, isn't it? So if you will take the different voltages, what you will get? You will get positive voltage and negative, both type of voltage, and current has to be the same. So same current means positive and positive negative. So same will be positive only. So it is giving you operation in first and second quadrant. Okay. That means the only option correct is option number B. Okay. Nilmesh, how option D is correct? That means Divya was absolutely correct. Okay, so we have option A, which is correct only here. Is that clear, Nilmesh? And what about others? Anybody else who has solved this question? We want to have the switch realization in first quadrant only. Okay, so IGBT, it will give you first quadrant operation. This combination and a MOSFET, it will give you first and fourth quadrant. If we talk about this combination, we have BJT, we have diode. Okay, so they are connected in parallel. In parallel, what happens? In parallel, the voltage is same, current is different. Okay, so if we have to take the same voltage and different current, we will get this switch realization for this. So which is not matching our requirement. In option D, we have this combination. Along with that, we have a series diode, isn't it? And diode is connected in this manner. So this ray switch you have already realized. And for this diode, if it is connected in this manner, this is the switch realization. Now they are connected in series. So in series, what will happen? Common current you have to take and different voltage you will be taking. Common current is positive current, different voltage will be positive and negative, so you will get switch realization in first and second quadrant, okay, which is not matching our requirement. So that means option number B is the only option which is correct, okay. So this is also wrong. Fine, very good. So Divya has given a correct answer. Nilmesh, you also have given a correct answer, okay, but before checking all the option, just don't give any option, okay, which is correct. So this is how we could have solved this question. What to look forward for switch realization? Voltage blocked during the off condition and current carried by the switch during the on condition. These are the two things that you have to look forward, okay, while realizing a switch. So if you are done with this question, can you answer this question? Just see. So in this we have this switch realization, this combination, and what will be the IV characteristic of composite switch. So how this particular combination will be realized, okay, this is what you have to tell here. It will give first and second quadrant, or it will give you second and fourth quadrant operation, or it will give you third and fourth, or it will give you first and fourth. So this is what you have to tell here. So let me give you timer. And let me see whether you can solve this question. And your time starts now. So Nilmesh is saying option D. What about others? So let me be aside so that you can have a proper look to this question, okay? First we have a BJT and a parallel diode. Then we have a series diode, and then this combination again has a parallel diode, okay? So what will be the switch realization for this combination? So both Nilmesh and Divya has got an answer D. What about others? Are you getting any different answer? So I got an answer D. So let us check whether D is a correct answer or not, okay? So we have to realize this switch combination, in which what do we have? We have, first of all, there is a BJT, okay? Then we have a parallel diode connected to this BJT. After that we have a series diode connected like this, and then we have an anti-parallel diode as well. Okay, this is the switch combination given to us. Nitya Sri is also saying D. Very good. Good morning, Nitya. So guys, if you see this combination, isn't it? We have realized this particular combination already, isn't it, in the last problem. Just see here. In the last problem, we have already realized this combination. And what type of realization it has given to us? It has given us a realization in first and second quadrant. So can I pick this from here, from the last problem? So what switch realization this will give you? It will give you a switch realization in first and second quadrant. Okay, it will give you a switch realization in first and second quadrant. Now after that, This we have realized. Now you can see we have a diode connected as well. Okay, and how this diode is connected? This diode is connected in this manner. Okay, this will be the voltage and this is how it will be carrying the current. So if you see, if you realize this particular diode, it will be able to block positive voltage, but it is carrying current in negative direction. Okay, so this is the switch realization for this diode. Now this combination and this diode, they are connected in parallel. And what happens in parallel? In parallel we have same voltage but different current. So out of these two combination, you have to pick the same voltage and different current. Okay, so if we combine both of them, we have to pick the same voltage and we have to pick different current. Okay, so this is V and this is I. Same voltage, different current. So what is the common voltage of these two? The common voltage of these two is, and we haven't written current here, so current is positive. Okay, so common voltage of these two is positive, while the different current is, here we are having the current positive and here we are having negative current. So we will pick both the currents. Okay, so just see, this is how we will get the switch realization for this particular combination. First quadrant and the fourth quadrant. Okay, and yes, option number D is having the same thing. So all of you are correct. Very good, excellent. Okay, so this is how you could have realized this composite switch. Okay, why we are making composite switches? Because sometimes single switch is not able to justify an application. In that case, what we have to do? We have to make a combination of switches, connecting them in series or in parallel. Okay, very good, excellent. So each one of you has given a correct answer. Now moving towards the next question. Is that V means VCE? Yes. Yes, this is the applied voltage. Okay, you have this terminal P, you have this terminal Q, so you will apply this voltage here as well. Okay, this is the applied voltage we are talking about. And if the current will flow, it will flow from P to Q, then it will be considered as positive. Otherwise, if it will flow from Q to P, it will be considered as negative. Okay, so Madhu, is that clear? If you will take individual switches, of course, this voltage which you have applied across P and Q is absolutely the VCE voltage of the BJT. Okay. Now what about this switch? So we are the same question we have here. We have a composite switch combination, and out of these combination we have to choose which one will be the correct option. Okay. So let me give you time. I hope that you are able to solve this question as well. Any of these might be the part of your gate exam. Okay, in the upcoming gate exam, you can see any of these switch combination, or the learning that you are having from here will be very much useful for you in the upcoming gate exam. Okay. And this year, the power electronics subject is going to be a very much scoring subject, because last year it has not given as many questions as it has supposed to be. Okay, so this year it is going to be the turn for power electronics. Surely you will get marks around 11 to 13. Okay, so be very well prepared for the power electronics. So focus on this question. Neil Mace has given an answer D. Okay, Neil Mace is saying it is a 4-quadrant switch. Yes, which is correct only. Very good, Neil Mace. Nitya is also getting D. Very good, Nitya. So what about Divya, Madhu? So the time is over and D is the correct answer. Very good. Nitya and Nilmesh. Very good. So guys, just see this particular combination. So in this combination, what we are having? Just see, we are having two paths here. Okay, so from A through the diode D1 and through this IGBT and through D4 we can move to B. This is one path. Okay, this is the one path available. And let me take this path first of all. So what do we have? We have a diode. Okay, then we have a IGBT. Then again we have a diode. Okay, so first of all, realize this particular combination. This is point A and this is point B. So how you will apply voltage here? You will apply voltage from point A to B. A will be positive and B will be negative. So what will be the switch realization of this combination? So just see, this is IGBT. IGBT will have a switch realization in first quadrant only, isn't it? Divya is also saying D. Very good. So it will have a switch realization in first quadrant only. Okay. Now this is the diode. And the way it is connected, it will give you a switch realization in which quadrant? Second quadrant. Okay. It will block negative voltage and it will carry positive current when it is on. Same way this diode will also be having. So if we talk about this diode, V, minus V and I, what will happen? Same switch realization it will also give. So now we have three switches which are connected in series and individual switch realization is known to us. Now what happens in series? In series the current is common but the voltage is different. Okay. So if we take the combination of these three, what we will be getting? Just see. In series what happens? In series we have same voltage, different voltage but same current. Okay. So what is the common current of these three? Positive. And what is the different voltage combinations? Here we have negative, positive, negative. So different voltages we have to take. So we will be taking both the voltages like this. Okay. So just see. It will give you first and second quadrant. Okay. Now if you see, so this particular switch combination we have realized. Now if you look into this switch, we have another combination available as well, in which we may go like this as well. Just see, this can be the another path. Isn't it? This can be another path. So if we just draw this particular path, what we will be getting here? So see, we have this diode, okay? Then we have an IGBT. Then again we have a diode like this. Okay? And this point is A, this point is B. Now you have applied voltage like this again. So just see. If we look into this combination or if we look into this combination, whether they are reversal of each other, I hope you all agree with me, isn't it? They both are the reverse of each other, isn't it? So when you have reversed the direction of switch, what will be the switch realization? You have to reverse the switch realization again. So you don't have to realize it again. Whatever you have realized here, you are reversing the combination. So reverse this switch realization as well, okay? So just reverse the voltage and currents here. If you are going to reverse the voltages, so we have both voltages. So reversal will give us both voltages as well. And current we are only having in positive direction. Reversal will give us current in negative direction. Okay. So you have realized both the paths, isn't it? You have realized both the path, the forward path for the current and the reverse path for the current. Now these combinations, just see, we have realized the combinations. Now these combinations, how they are connected with each other, parallel or series? How they are connected with each other, in parallel or in series? Tell me guys, these two combinations that we have realized, they are connected in parallel or series? They are connected in parallel. Okay, so they are connected in parallel. So just see, if we take the parallel combination of this characteristic, this switch realization and this switch realization, what we have to take in parallel? So if you will combine, after combining figure 1 and 2 in parallel, so what will happen? Just see, this is figure 1, I am calling this figure 1, and this is the figure 2 that you have. If you are combining them using parallel combination, what will happen? In parallel you have to take the same voltage and you have to take different current. Okay, so if we are going to take the same voltage, okay, so voltage is positive negative, voltage is positive negative, so we have to take same voltage, we will be taking same here. Current we have to take different. Okay, yes, different current means here the current is positive, here the current is negative, you have to take different current, means you have to take both the current. So this will be the combined switch realization of this particular switch, okay, which is giving you 4 quadrant operation. Yes or no? Which is giving you 4 quadrant operation. So which option will be the correct option? Option number D, which you all have stated to be the right one. Okay, excellent, very good. Okay, so this is how, those who are not able to solve this particular question, this is how you have to approach for these kind of combination. Okay, this is how you have to approach for these kind of combinations. Okay, now I'm giving you another task. For example, if suppose you have this switch combination, if this is the point A and this is the point B, okay, so what could be the possible switch realization of this? This you can try at your home. Okay, now we have BJT with anti-parallel diode, BJT plus anti-parallel diode, and if you see 1 and 2, these combinations are just reversal of each other. Okay, and they are connected in series. Okay, so if you have this combination, how to approach for this? Again, this will give you a 4 quadrant operation. Okay, so just try this at home. Okay, so this I am giving you as homework problem. You can try this as at home. This can be the case as well. Okay, now just focus on this question, a very conceptual one, and it is based upon MOSFET, an ideal device in power electronics. Yes, Neil miss, it will give you 4 quadrant operation. Okay, that's right. Let me read out this question, which is very important, and it is on MOSFET, an ideal and very much used device in power electronics. Which of the following is or are not correct? You don't have to find the correct statement, you have to find not correct statement. Okay, MOSFET is a majority carrier device, MOSFET is a passive switch, MOSFET has higher switching frequency due to less recovery time, and power MOSFETs are slowest among all devices. Okay, so which one is not correct? You have to find which one of these are not correct. Okay, your time starts now. Till now you have answered all the questions correctly. Okay, that's very good. That shows that you people are in great touch of power electronics. So Divya is saying B and D are not correct. Okay, B and D. What about others? Take your time. Okay, Nilmesh also saying that B and D are not correct. Very good, Nitya. So Nitya, Divya and Nilmesh, they are on the same page. B and D. Okay. Any other answer? Last 30 seconds we have. Anybody else who's giving other than B and D to be the wrong answer? You have to find which of these are not correct. Okay, you don't have to find the correct option, not correct option. Yes, you people are absolutely correct. Okay, so B and D are not correct here. Okay, so this will be the options which you have to choose here. Now, what is given in option 1? MOSFET is a majority carrier device. Yes, that's absolutely correct. Majority carrier device versus minority carrier device. What are those devices? Those devices in which both type of charge carrier participate, electron as well as hole. They are called as minority carrier. But if only one type of charge carrier, either electron or hole participate, the device is said to be majority carrier device. Okay. So MOSFET is a majority carrier device. This is a correct statement. Okay. Let me mark it correct. MOSFET is a passive switch. We have two kinds of switches, active switch and passive switches. So passive switches are those switches in which there is no control element, and active switches are those switches in which we have control element, isn't it? So in MOSFET we have the third element, which is gate. Other than source and drain, normal element terminals, we have the gate terminal through which we are turning it on and off. So it is a controllable device and it is a active switch. Okay, so switches which are having control terminals are active switch. So this is not correct. MOSFET is not passive switch. Passive switch is diode, isn't it? Because it does not have any control terminal. Then in the third option we have MOSFET has higher switching frequency due to less recovery time. This is correct. Okay, this is the correct statement. Okay, why this is so? Because only one type of charge carriers are participating in conductance. So when you are recovering them back, they will be recovered very easily and very soon as well. So if the recovery time is less, means off time is less. So total time that we have, which is on time plus off time. So this time will be very less in MOSFET because you only have to recover one type of charge carrier. So ultimately your T will be less, and if T is less, the frequency will be very high. Okay, so just see, MOSFET has high switching frequency, yet that's correct, due to less recovery time. Yes, this is correct. So this option is a correct option. Now MOSFETs, D is saying power MOSFETs are slowest among all devices. How can this be correct? Okay, you can see in option C, we will be requiring less recovery time. So they are fast acting devices, not a slow device, isn't it? So this is not correct, and you have to find not a correct option. That's why you have chosen B and D. Absolutely correct. Fantastic. Okay, Divya, Nilmesh, Nitya, absolutely correct. So this is an ideal choice of question for MSQ questions from power electronics. Okay, and if you are able to do it right, means conceptually you are at the right platform. Okay, conceptually you are standing very right in power electronics. So let's move into the new question. Yes, these are the questions from switching power losses. These are very important. So what has been given here in this question? For a power transistor supplying a resistive load, the voltage and current variations during turn on and off are shown in figure. The ratio of energy dissipated during on and off transition at the frequency of 83.33 kilohertz will be what? Okay, you can see this is the turn on transition and turn on time is given. So during turn on transition, voltage is having maximum to minimum transition, current is having minimum to maximum transition. Similarly, during the off time, current will be having maximum to minimum transition, voltage is having minimum to maximum transition. Okay, is this matching the right, is this matching with the characteristic that normally BJT have, the dynamic characteristic of BJT? Yes, it is. Okay, so you can use direct formula. This is a hint. Okay, so let me give you time. How much time do we have for a question in GATE exam? We have 3 minutes. Okay, but I am giving you only 2 minutes for this question, because you can save time in these kind of questions and you can utilize that time in other questions. Okay, so let's try everyone. Nilmesh has got an answer 1 by 2. The ratio will be 1 by 2. Be very clear. What we have to calculate here? We have to calculate energy loss during on transition and the ratio of it with energy loss during the off transition. This is what you have to find here. Okay. So I am having an option 1 by 2. One by 2 means 0.5, okay, because this is NAT, so you have to write 0.5 here. Come on guys, this is very easy. Okay, if you are my classroom student, you can very easily solve these kind of questions as Nilmesh has done. And be ready for this kind of questions to be a part of the upcoming GATE exam. Divya is also getting 0.5. Very good, Divya. 0.5 is the correct answer. Okay. What about others? Last 10 seconds. One by 2. Very good, Nitya. So just see, this is the characteristic given to us. Okay, and what we have discussed is, if suppose the voltage and current transition are like this, okay, in on time or in off time, then you know that energy loss you can calculate directly. So what will be the energy loss? It will be equals to VCC into ICS divided by 6 into T on. Okay, this is the energy loss during the on time. And similarly, what could be the energy loss during the off time? So during the off time, it is having the same formula, VCC into ICS divided by 6 into T off. Okay, so if that characteristics are exactly matching to this particular shape, we can directly use these formulas. Okay, what is VCC? So this voltage is basically VCC. Okay, and this maximum current is basically ICS. Now what we have to calculate? We have to calculate the ratio of these two. So we have to calculate what will be E loss during on transition divided by the E loss during the off transition. Okay, so if you will put the value VCC ICS divided by 6 into T on upon VCC ICS divided by 6 into T off, so you can see this will be cancelled, and what you will be getting? T on divided by T off. So what is T on? It is 4 microseconds. What is T off? It is 8 microseconds. So you will get 1 by 2 or 0.5 as answer. Okay, this is how you have to approach for this question, which Nilmesh, Divya and Nitya has already solved. Very good, excellent. Okay, so answer will be 0.5. So this is how you have to approach for these questions if you have the similar characteristic. Okay, so if your characteristic is exactly matching, this is like a gift, isn't it? We can directly use these formulas and we can approach for the further solution. But If the characteristic is not matching to this characteristic, you have to calculate energy loss. Okay. For example, just see this question. So what do we have in this question? The voltage across and current through the MOSFET. It can be MOSFET, BJT, IGBT, any switch. During on transition are shown below. So just see. The voltage, how it is varying, the current, how it is varying is given during the on transition. If the switching frequency is 100 kilohertz, the power loss in MOSFET will be. Okay. Now whether this characteristic is an exact match of then an ideal one. What is an ideal one? If you have the characteristic like this during on and off transition, this is an ideal one. So this is not matching with this particular characteristic. You are having a different shape. So if you have a different shape, you have to calculate energy. Then you have to divide it with the time period. This is how you can calculate the power loss. Okay. So how to calculate energy? The energy you can calculate by using this formula. And what is PT? PT is basically Vt into It dt. So this is the hint. And then power, it will be energy over time period. So now let me give you time, and I have given you this hint how you can approach for this question. Now it's up to you. Let me see. You can solve this question or not. Okay, take your time and don't be in a hurry. I want the correct answer. Take your time, guys. Don't be in a hurry. Okay. I want the correct answer from each one of you. And don't do any calculation mistake. $750. Yes, that's correct. Very good, Nilmesh. 750 watt is a correct answer. And what about others? Do you want more time for this question? Okay, let's see how we can approach for this kind of question. Okay, so what I have told you, that how to approach for calculation of energy. Okay, so energy will be basically energy that you have to calculate here first will be, just see, we have two times here. First we have 10 microseconds. Okay, and during that what will be the PT? Then we have the other time which is 20 microsecond, and then what will be the PT? This is what you have to calculate, and you will calculate the energy. Okay. Now you know that PT is basically Vt into It. Vt It dt plus Vt It dt. This is how you can write it. Okay. Now just check for 10 microseconds. So during this 10 microseconds you are having voltage as constant. So can I take this voltage out? So I can take the voltage out and only current will be there, because current is varying. It is not constant. Okay. Similarly, if we see in 20 microseconds, the voltage is varying while the current is constant. So can we take the current out and only voltage will be there like this. Okay. Now if you see, this is nothing but the area of IT. Okay, and this integration is nothing but the area of VT. Okay, area of IT curve, area of VT curve. So can I write the values here right now? Just see, E will be in the first integration. What is the value of VT? It is 50. Okay, into this indicates the area under the current curve. So just see, this is the area under the current curve for 10 microseconds. This area you have to calculate. So this is making a triangle. Area of triangle will be half into height and width. Okay, so half into, what is the height? Height is 10 ampere. Okay, and what is the width? 10 microseconds. 10 into 10 to the power minus 6. So we are done with the first integration. Then for the second, IT is constant. Okay, just see, IT is constant at 10 ampere, but the voltage is varying. Okay, and if you see, voltage varies like this. So what you have to calculate? You have to calculate the area under this voltage triangle. Okay, so how you will calculate that? Half into, what is the height of the voltage? 50, and what is the width? It is 20 microseconds. Just see, you have to put the values like this. Okay, now when you will solve this, the answer that I am having is 7500 into 10 to the power 7500 into 10 to the power minus 6 joules. That will be the energy. I hope you are getting the same answer, Nilmesh, for the energy. Okay, then if we talk about the power, power will be energy over time period, or energy into 1 by time period as the frequency. Okay, how much is the frequency given to us? 100 kilohertz. Okay, so just put the values here. E is 7500 into 10 to the power minus 6, and what is the frequency? 100 kilohertz. So write 100 kilohertz here. 100 into 10 to the power 3. So what we will be getting? We will be getting 75 watts as the power loss. Okay, I think in this way, Nilmesh, you also have solved this question. Yes or no? And what about others? Why you people are not getting answer yet? Too much time is over. So much time is already spent on this question. So is that clear right now? To others as well? Madhu, Divya, Nitya, Selja. Is that clear? This is how you could have approached for this kind of question. Okay. Tell me your concern. Is this clear? Very good. Nitya is also getting 750. Very good. So did you get this difference? Very good, Divya. So did you get this difference? Two different problem, two different approach. Okay. This problem we have applied the formula and then we have solved this problem. In the last case we have directly written some formulas. So if you have that particular shape like this, which we had in this particular question, you can directly use the formulas. Okay, VCC ICS by 6 into T on, VCC ICS by 6 into T off. But if you are having a shape other than this, which you are having in this particular question, then you have to solve like this. Okay, this is what we have done and we got the answer. So I hope this difference is clear to you. You may get a question of either choices. Okay, either the first case or the second case in the exam. Okay, so this is how you have to approach for these kinds of questions. Now, questions from commutation. So we have covered switch realization, we have covered the switches, and we have covered the switching characteristic of the switches as well. Now comes the term for calculation of now comes the term for commutation circuit. So just see this question. Let me read it out. The current commutation circuit is shown in the figure below. So this is the current commutation circuit which we have. We don't have to remember the circuit because they will already give you They already have given this. If the capacitor and inductor has the value of 20 microfarad and 7.5 microhenry, the voltage across capacitor for which the SCR gets turned off will be. Okay, you have to find when the SCR is getting off, what voltage the capacitor is applying, what capacitor voltage is acting as a reverse bias voltage across the switch. This is what you have to find here. Okay, so your time starts now. And what I can see is that you people have answered all the questions correctly. That means you are in good touch of the subjects. Okay, and which is very nice of you. Okay, because this year power electronics is going to give you more number of questions in the exam. If you are well prepared for power electronics, means you are well prepared for the GATE exam. So in this question we have to calculate when the switch is getting off, what voltage the capacitor is applying, amount of voltage. This is what you have to calculate. Take your time, don't be in a hurry. You can solve this question as well. So maybe you are not able to memorize the formula, isn't it? And you don't have to. Just see here how you can get to the formula. So the current flowing in this LC combination will be what? The current flowing in this LC combination will be IC. Okay, and what is this current IC? This current across this LC combination will be IP sine omega naught T, or what is IP? Vs under root C by L sine of omega naught T. So this is the current. Okay, now there is a current flowing in this main thyristor as well, isn't it? There is a current flowing in this main thyristor as well. Okay, you can calculate in the meanwhile. Okay, now if you see, if we apply KCL at this node, okay, so KCL at this node will give you what? KCL at this node will give you ITM plus IC. This will be equals to I naught, isn't it? Or what we can write here is that ITM, this will be equals to I naught minus IC. Okay. Now what is the purpose? The purpose is to turn off this main thyristor. This is the purpose of the commutation circuit. So what we want to have? We want to have ITM to be equal to 0. That means we want to turn off the main thyristor. Okay. Suppose if you don't remember any formula, this is how you can approach for it. ITM has to be 0. Now when you can get ITM to be 0? This is possible when I naught and IC, they are equal to each other, isn't it? I naught and IC, if they are equal to each other, what is IC? IC is IP sine omega naught T, isn't it? So what will be the value of omega naught T here? That will be equals to sine inverse I naught over IP. Okay, and this instant omega naught T, okay, this is the time at which what voltage the capacitor is applying here, what voltage the capacitor is applying here will be acting as a reverse voltage across the thyristor and it will get off. So capacitor, it might be having a reverse polarity at that time, okay, and that's why the thyristor is getting off. Yes or no? So during that instant, what could be the voltage applied across the thyristor by the capacitor? This is what you have to calculate, okay. So two things we are very sure about here, that IC current is given by this amount, and you also know that the capacitor voltage Vs will be equals to Vs cos omega t at any time. It is following the cos curve. We know these things from LC circuit concepts. Now this omega t, let me call this omega t dash instant or t2, whatever you want to write, you can write omega t dash instant, which you have calculated sin inverse I naught upon Ip, where your current is getting 0 and thyristor is getting off. So if we put this instant in this formula of Vs, we will get at what voltage the capacitor is applying. What I am trying to say is that we have Vc is Vs cos omega naught t. Now Vc, it will be equals to the reverse bias voltage when the thyristor is getting off, okay. So that voltage the capacitor is applying at this instant, okay. So let me put this instant, omega naught t dash. So what is the value of omega naught t dash? Is sin inverse I naught over Ip. Just see. Now this is the voltage which will be acting as a reverse voltage across this thyristor applied by this capacitor, okay, when the polarity is reversed. So you got the value. Now just put the values and you will get the answer. So Ip, how you can get Ip? Ip is Vs under root C by L. Okay, what is Vs? 220. And how much is the C and L? 20 microfarad and 7.5 microhenry. 20 microfarad and 7.5 microhenry. Okay, so how much Ip we are getting? Can anybody tell me how much is the value of Ip? 358.6. This is what I am having. Are you getting the same? 358.6. Okay, now come back here. At this is how you can remember it. Okay, just is everything fine there? Are you able to listen to me, Nilmesh? Are you people able to listen to me? Any problem that you are facing right now? Everything is correct? Very good. So just see, this is the important formula and every gate aspirant know about this. If suppose you have forget this particular formula which is important, this is how you can approach for this particular formula, isn't it? This is how you can approach. So make all the formulas approachable for you, and this is how you can solve all the questions. So we are done with this problem. I hope you all are getting the same answer. Moving towards the next question. So this is related to voltage commutated chopper. So what we have here is a voltage commutated choppers operating at 1 kilohertz is used to control the speed of DC motor as shown in the figure. Okay. The load current is assumed to be constant at 10 ampere. So what we have as the load current I naught, it is 10 ampere. The ratio of peak current through thyristor Tm and Ta will be. We have to calculate what will be the ratio of thyristor current across Tm and Ta. Okay, peak current across Tm and Ta, what will be their ratio? This is what you have to calculate. Okay, I hope you can solve this question. So let me give you time. You have to calculate the ratio of peak currents across the main thyristor and the auxiliary thyristor. 1.23. This is what Nilmesh is saying. Okay. Divya, Nitya, what is your answer? Last 30 seconds. Okay, Divya is getting 2.41. We will check Nilmesh. Okay. So we have to find ITM peak and ITA peak, and then we can approach for this question. Okay. So just see, this is ITM current. Okay. And this current will be the IC current, okay, which is coming through this particular circuit. Now can you tell me, and this is I naught, we have this current as I naught. So if you apply KCL at this node, ITM is basically what? ITM is basically what you have as ITM is, ITM will be I naught plus IC. If you want to calculate ITM peak, that will be equals to I naught plus peak current of IC, which is IP. Okay, or I naught plus Vs under root C by L. Now can you calculate this current? I naught is given to you 10 ampere plus Vs is 300 volt under root C by L. What is the value of C? 1 microfarad. Okay. Then what is the value of L? 50 microhenry. So how much we are getting from here? What is the value of ITM peak? Nilmesh and Divya, what is the value of ITM peak that you are getting from here? 52.426. Divya, you are getting the same value as well? 52.426 ampere. Is this correct? 52.426. Okay, this is what Nilmesh is getting. Divya, just confirm it. So this is how you will calculate ITM peak. Okay. Now what will be ITA peak? So just see. Initially your capacitor might be having this polarity. Okay. Because of this polarity your TM will be on. Finally your capacitor will be having this polarity. So when it will be having this polarity will turn it off. And this polarity will turn it on. Yes or no? So when this will be off, there will not be ITM. But when this will be off, you will get current. Okay. So when the current will be flowing through this circuit, what current the ITA will be carrying? Just see, ITA will be carrying a current of I naught. Isn't it? Because TM will be off at that time. So if TM will be off, there is no path for ITM to flow. So right now we are having this IC current which is flowing across TA, and that current is also equals to I naught current, and diode is also reverse bias. Okay. So what could be my current across ITA? Okay. So if I talk about the ITA peak current, so my ITA peak current will be nothing but the I naught current. Okay. And which is given to us. So if we come back here and put the values, so what do we have? ITM peak is basically 52.426 and ITA peak is exactly equals to I naught, and I naught is given to us. How much is I naught? 10. So what we will get? We will get 5.24 as the ratio. 5.24 will be the ratio, which I think Nilmesh, you have given an answer 1.23. Divya has given initially 2.41, then he has She has changed her answer to 5.24, which is correct. Okay. So Nilmesh, have you spotted where are you making a mistake in this question? Answer will be 5.24. Okay. Is that clear? Okay, so let's move for the next question. So now just see this question. This is a very good question. So what has been given here? The circuit shown in figure below has VCC equals to 70 volt, L equals to 210 millihenry, R equals to 20 ohm, T1 equals to 10 milliseconds and T equals to 100 milliseconds. The peak current and peak energy storage in inductor will be. This is an MSQ question. What you have to calculate here? Peak current and peak energy across the inductor. You have to calculate IL peak, okay, and you have to calculate energy stored across the inductor as well. These two things you have to calculate. So can you attempt this question? Okay, let me give you time. This is a very good question. If you are able to do this as well, you can do any question. Its peak will be IC peak. No, Nilmesh. IC current, ITA will be carrying IC current, but IC current will now become what? IC current is forced to become I naught right now, isn't it? IC current is forced to become I naught. See here. When the capacitor polarity will be reversed, diode will also be off, main thyristor will also be off. Now TA will be on and it will be carrying IC current, and this IC current is also becoming equal to I naught. So IC is becoming equal to I naught right now. Okay. IC current is becoming equal to I naught. It is not having that sinusoidal shape right now. Okay. IC is the current across capacitor right now and it is equals to I naught current. Okay. So it is forced to become I naught. Focus on the waveforms that we have drawn. There you will understand that IC will become minus of I naught. Okay. Now what about this question? You can solve this question. And this is very important. This can be the part of GATE exam. So, what about this question? Just see. We are having a transistor and all these devices are connected like this. When you are giving a gate pulse, okay, to the base, when you are giving the base a signal, okay, of duration T1, then your transistor will be in on state. Yes or no? When you will be giving this base signal to your transistor, it will come into on state. Okay. Now when the transistor will be coming in on state, inductor will be having this polarity. Okay. And it will be storing energy. Yes or no? During that time, diode will be off. Fine. Now when you are giving this pulse, okay, your transistor will be in off state. At that time, the inductor might be having this polarity. Okay, at that time inductor might be having this polarity. So this will be the beginning polarity, this will be the end polarity. Okay, so diode will be off initially and then finally it will be on in the next cycle. So for this polarity it will be off, for this polarity it will be on, isn't it? So when it will store energy, it will store energy when the transistor will be in on state. Okay, and current across it will be flowing. What we have to calculate? Peak current. So peak current we can calculate in either of the time, on time or off time. But you can see on time is mentioned to us. So we can calculate the current during the on time. Okay. Now you tell me when the transistor is on. Okay. At that time what we will be having? When transistor is on. This is the transistor. So when the transistor will be on, at that time you will be having a circuit like this. Just see. Isn't it? You will be having a circuit like this. This is the inductor voltage and inductor current is flowing in this direction. This is the VCC voltage. Okay. Now when you will apply KVL, what you will get? You will get VL equals to VCC. Isn't it? You will get VL equals to VCC. And you know that VL is also equals to L DIL by dt, which will be equals to VCC. If I want to calculate IL from here, this will be equals to what? 1 by L integration, time duration will be T1. Okay. Time duration will be T1 into VCC dt, or this current which I am calculating for this duration T1, this will be equals to VCC into T1 by L. Okay. Now put the values. What is the value of VCC given to us? 70 volt. What is T1? T1 is 10 milliseconds. So 10 into 10 to the power minus 3 divided by what is L? 210 millihenry. Okay. So when you will solve it, what you will get? B answer. Okay. B is the answer that you are giving. 3.33 ampere. Okay. I am getting 3.33 ampere. You are getting 3.5. Okay. Similarly, if we want to calculate the energy at time T1, how you will calculate that? This will be equals to half into Li square. Okay. So whatever is the current you have calculated, square it and you will get this value. So half into what is L? 210 millihenry into what is IL T1? 3.33 square. When you will do this, you will get an answer 1.16 joule. Okay. So which option will be correct? Option number A and option number C will be the correct option. Okay. Just see how you can solve this question. Now, there is not any rocket science in this question. Okay. You have gone through the commutation circuit. You have gone through some big topic as well, and this is a very silly question, isn't it? You have to apply the concept of inductor charging discharging here, isn't it? And when the particular switch will be on, when it will receive the gate pulse. When it is not receiving a gate pulse, means it will be in off condition. So when the switch is getting on or off, you have to apply the transition as well, and these are the formula that you will be using anytime. Okay. Yes, 3.33 is the correct answer. So is that clear to everyone? Give me a reply. Is that clear to everyone? Okay. So this is an MSQ type of answer question. Option A and C are correct. Okay. Very good. So now this is all about the first chapter. Okay. Now we are moving into the next chapter. Okay. And I hope that you guys are enjoying. If you want to have the same flavor in classroom, okay, do join our Telegram group, in which you will get all the PDF of this section and notifications of several exams as well, and a lot of information about GATE and other exams as well. And you may join our courses as well, which is having all these features. Okay. Now moving towards the next chapter, which is DC to DC converter. So what are the important topics in DC to DC converter? The important topics are buck converter, boost converter, and buck boost converter. What is the weightage? The expected weightage is 3 to 4 marks, and this year you are definitely going to get 2 questions consisting of 3 to 4 marks from this chapter. Okay, so if you are very well prepared with this chapter, you are going to rock in the GATE exam. Okay, and for that you need a very good amount of practice, and that we will be doing here in the next 1 hour. Okay, so let me move towards the next question, or the first question of this chapter. So just see this question. What has been given here is a step down chopper fed from 220 volt DC is operating on a chopping frequency of 1250 Hz and a duty cycle of 0.5. The ratio of RMS to average inductor current will be what? Okay, so what is given to us? We have been given the chopping frequency. So frequency is given to us 1250 Hz. Duty cycle is also given. Duty cycle is 0.5. Okay. Then what we have to calculate? We have to calculate the ratio of inductor RMS to average current. Okay. So what will be the ratio of RMS inductor current to the average inductor current? This is what you have to find. Okay. And your time starts now. And guys, don't focus on these options. Okay, this is an NIT type of question. You have to answer it. What will be the answer? Okay, don't focus on these options. There will not be any option will not lie among these. Okay, this is a typing mistake. So you have to give an answer. What could be the possible answer? You have to find the ratio of RMS to average current. Okay. So I'm converting this to be an NIT type of question. You have to find what could be the ratio of RMS inductor current to the average inductor current. Okay. So for that you need to have formulas. Don't be in a hurry. Take your time and give me the answer. Okay, let's check it out. So what we have to calculate? The ratio of RMS to average inductor current. Okay. What converter we are having? We are having a buck converter or step down converter. So for a buck converter or step down converter, what is the inductor current waveform? The inductor current waveform is like this. Just see. The inductor current will be increasing and it will be decreasing in the off time. In on time it will be increasing, in off time it will be decreasing. So if this is my on time, okay, and if this is the total time, on time means D into T as well. So it will be increasing from certain minimum to maximum value. Okay, this is my inductor current. And what do I call this particular value? this amount will be what? This amount will be peak to peak ripple delta IL. Okay. Then how much will be this amount? How much will be this amount? This amount will be delta IL by 2. Okay. And this value will be IL average. Okay. This value will be IL average. Now what will be the value of this IL average? Just see. IL current that we have here is a combination of two current, IC plus I naught. Okay. So if you see, IL is combination of IC plus I naught. So if you are going to calculate average inductor current, this will be equals to average capacitor current plus average current I naught. And average capacitor current, you know, this is equal to 0. Okay, because capacitor charges and discharges. So average capacitor current is equals to 0. So what will be my average inductor current? So my average inductor current, this will be equals to I naught. Okay. So this is what we have calculated. Average inductor current will be I naught. So I may write here average inductor current to be I naught. So this is what I have calculated. Now I have to calculate the RMS value of this current. Okay. So how to find the RMS value of this current? So RMS value of this current, this is having DC plus ripples as well, AC content as well. So it will be IL average square plus delta IL by 2 divided by root 3 square. This is how you have to find the RMS value of a triangular waveform. Okay, we are not finding IL RMS. In fact, this formula that we are using is the formula that we are using for, we have to use for finding the RMS value of this triangular waveform shown to us. Okay, same we have applied here. Okay, so what are the values required here? Just see. In order to find the ratio, we need the value of IL average, we need the value of delta IL by 2, and then the task is very easy for us. So let us find these values. Okay, so just see. If I have to find what will be IL average, IL average is basically I naught. I naught will be V naught by R, and V naught will be dVs over R. Okay. Now all the values are given to us. What is D? D is given 0.5 and Vs is 220, R is 10 ohm. So 0.5 into 220 divided by how much? 10 ohm. So how much will be IL average? Okay. So IL average, if you will calculate from here, you will get 11 amperes. Okay, it will be 11 amperes. Then in order to calculate IL RMS, we need the value of delta IL, peak to peak ripple current. So peak to peak ripple current, what is the formula in case of step down or buck converter? D1 minus dVs over FL. And what is the formula for boost converter and buck boost converter? It is dVs over FL. Okay. So we have step down converter. So it will be D1 minus dVs over FL. Now put the values. 0.5, 1 minus 0.5 into 220. Frequency is 1250 Hertz. And what is the value of inductor? 15 millihenry. Okay. Now when you will solve this, very good Divya, this is the right answer. Delta IL will be what? 2.93 ampere. You will get 2.93 ampere as the value of delta IL. Okay. Now come back here and calculate this. IL average you have calculated 11. So square of 11 plus delta IL by 2 means 2.93 divided by 2 divided by root 3 square. Okay. Now when you will calculate it, how much you will get? You will get 11.13 ampere. Okay. So now all the values are with us. If we want to find, we can find the ratio. So IL RMS divided by IL average, which can also be called as the form factor. So IL RMS you have obtained 11.13, and how much is IL average? IL average is 11. So you will get 1.01 as the ratio which Divya is getting. Very good, Divya. Excellent. If you are able to solve questions like this, you can solve any question in the upcoming GATE exam. Very good. Okay, what about others? Are you also getting the same answer? Okay, so RMS over average is also called as the form factor, isn't it? For an ideal DC, the form factor has to be equals to 1. If you are getting other than 1, that means some ripples are also there. Some AC content is also present. Okay. Very good, Nilmesh. Very good. So just see, this is how you can solve this question, and be ready for these kind of questions. They may be the part of upcoming GATE exam. Okay. So did you find this question to be a very good one? Very good. So let's talk about the next question. A buck converter produces 16 volt from 48 volt DC. Okay. Across 10 ohm resistor, the output voltage ripple must not exceed 0.48% at a switching frequency of 50 kilohertz, so that the converter operates at the boundary of continuous conduction. The RMS inductor current will be what? Okay, so what has been given to us? Just see. It produces 16 volt output voltage. Converter is buck converter. Output voltage is 16 volt. Okay, input voltage is 48 volt. Across the resistance of 10 ohm. So load resistance is 10 ohm. And output voltage ripple must not exceed 0.4%. So output voltage ripples, they are 0.48. And then we have switching frequency, which is how much? 50 kilohertz. And the converter operates at the boundary of continuous conduction. It is operating at the boundary of continuous conduction. This is the important line. You have to look into this line. It is operating at the boundary of continuous conduction, and then you have to calculate that what will be the possible RMS value of inductor current. Okay, and I am very sure that you people can solve this question. This is the given data, okay, and this is what we have to calculate, and I am very sure that you can solve this question very easily. Take your time, okay, but don't do any mistake. If you will put effort in memorizing the formulas, you will definitely mess up, because there are 3 converters and most of them are having similar formula. But if you have remembered the approach, how to get to a particular formula, you will be able to solve any questions, and you will be able to derive whatever is necessary equation required for the particular question. Okay, so look forward to the approach, not for the particular formula. And don't make yourself a pressure cooker. Okay. So let's see how to approach for this question. We have also calculated the RMS value in the last question as well, isn't it? But there we have continuous conduction. Here what has been given to us, that the converter is operating at the boundary of continuous conduction. So if it is operating at the boundary of continuous conduction, that means I minimum is also given 0 to us, okay, because it is operating at the boundary of continuous conduction. So I minimum is also 0. So now if I draw inductor current will be having this shape. Okay, I minimum will be 0 and it is having only I maximum. Now this will be the average value. Okay, this will be the average value, and this you know is the ripple current delta IL. And how much is this current? Delta IL by 2. Okay, this is the inductor current waveform for the present scenario when the converter is operating at the boundary of continuous conduction. Okay, so this is what we will get. Now can you tell me what differences will be there if you want to calculate IL average? How you will IL RMS? Formula still remains the same. Okay, so IL RMS, if you want to calculate, this will be equals to again the same thing, IL average, okay, plus delta IL by 2 divided by root 3 square. Okay, this is what you have to apply here. So you need to have two values. What? Delta IL and IL average again. Okay, so delta IL we need, and we need the value of IL average. Okay, so how to calculate all these things? Just see. If we want to calculate delta IL, okay, the formula is D 1 minus D Vs over FL. Okay, now here we have everything, just see, but we are not given with the value of L. Okay, so we have to calculate the value of L. How we can calculate the value of L? Critical inductance. Converter is operating at the boundary of continuous and discontinuous conduction, means the inductor is having a critical value, isn't it? So what is the value of critical inductance in case of the buck converter? 1 minus D R upon 2F. Okay, how to calculate this? If you suppose forget this, how to calculate this? Just apply this condition. IL average equals delta IL by 2. Once you will apply this condition, you will get the value of inductance. Okay, critical inductance. So critical inductance in case of buck converter or step down converter, it has a value of 1 minus D R over 2F. So put the values here and first calculate the critical inductance. So D value is, we don't have the value of D, so we can calculate D here. So for buck converter, okay, for buck converter, you know that output voltage is D times Vs. So what will be D? It will be V naught over Vs. What is V naught? 16. Vs 48. How much you will get? 1 by 3. Okay, so D value will be 1 by 3. So put the values here. 1 minus 1 by 3 into R. Whether we have the value of R? Yes. It is given 10 divided by 2 into, what is the frequency? 50 kilohertz. 50 kilohertz. So when you will put the values and you will calculate the value of LC, you will get 66.6 microhenry. Okay, you will get 66.6 microhenry as the value of L. Okay, just cross check whether this is correct or not. Okay, this is what I have calculated, 66.6 microhenry. Now come back here in this formula again and put the values of D, which is 1 by 3. 1 minus D will be 1 minus 1 by 3. Vs is 48 volt upon frequency is 50 kilohertz. And what is the value of L? 66.6 microhenry. Okay, so after putting the values, if you will calculate it, 1.84 is what Neelmesh is getting. Delta IL that I have is 3.20. Okay, delta IL will be 3.20. If you are talking about final answer, yes, Neelmesh is absolutely correct. Very good. So this will be the delta IL value. Okay. Now what will be the IL average? what will be the IL average value? Can you tell me what will be the IL average value? If you look into this formula, in this condition, whether IL average is not equals to delta IL by 2. So IL average is equals to delta IL by 2 here, isn't it? By looking into the waveform, we can confirm this. And what we will get? We will get 1.6 ampere as IL average. If you don't want to do this, you can also calculate IL average from this formula. IL average, you know, in buck converter is I naught. I naught is V naught by R, which is dVs by R. Okay. So if you will put the values 1 by 3, 48 and 10. So again you will get 1.6 ampere. So in both the way you can get this value. Okay. By looking into the waveform, you know that IL average has now become delta IL by 2. Delta IL you have already calculated, so don't waste your time. Otherwise, if you don't want to remember, you can calculate in this way as well. Now coming back to this formula, what is IL average? IL average is 1.6. So 1.6 square plus delta IL by 2. Delta IL by 2 means 1.6 again divided by root 3 square. Okay, and finally you will get an answer of 1.84 ampere. Okay, so Nilmesh, your answer is absolutely correct. Well done. I hope this is clear to everyone. Divya, Nitya, any problem that you guys are having in this question? So is this clear to everyone? Very good. Okay. So these two questions that we have discussed are very good question in which we have to deal with the RMS value of inductor current. First for continuous conduction, then for discontinuous conduction. Okay. So they may be asked in the exam, or you may be asked to calculate the form factor. Then you need the RMS and average value. This is how you have to deal with that. Okay. So moving towards the next question. This is the next question that we have. The switch shown in figure is ideal. The value of duty ratio so that the converter operates at the boundary of continuous conduction. Okay. What will be the value of duty ratio if the converter is operating at the boundary of continuous conduction? Okay. So at the boundary of continuous conduction, what do you know? Just now we have discussed. At the boundary of continuous conduction means I minimum is now 0. Okay, you only have I max. Okay, and this will be the average value of inductor current. So this is my IL average. This will be delta IL. Okay, and IL average will be equals to delta IL by 2, or we may also write it I naught. Okay, so converter is now operating at the boundary of continuous conduction. Continuous conduction, it is operating at the boundary of continuous conduction. That means you have I minimum equal to 0, or we can say that IL average is equals to delta IL by 2. Okay, if we apply this condition, what is the value of IL average? IL average is equals to I naught. Delta IL is equals to D 1 minus D Vs over FL. Okay, you will apply this expression many times so that you can be able to remember as well. Now what will be the value of I naught? So I naught can be written as dVs over R. dVs over R into D 1 minus D Vs over 2 FL. Fine. Now just see what will happen. dVs and dVs will get cancelled. Then we will get 1 minus D. This will be equals to what? This will be equals to 2 into F into L upon R. Or sometimes it might also be written as 2L upon RT. Okay. Or what will be the value of D? D value will be 1 minus 2L upon RT. So this you can store in your memory. If the converter is operating at the boundary of continuous conduction, I minimum will be 0. And what will be the possible value of duty ratio? 1 minus 2L upon RT. Okay. 1 minus 2L upon RT, this will be the value. Now if we calculate this value, D equals to 1 minus 2L upon RT. This is the expression and we need the final value. Okay. We may also write it 1 minus 2L upon R. 1 by T might be written as F because frequency is given here. So 1 minus 2 into, what is the value of L? L value is 5 millihenry and the frequency given is 100 kilohertz. 5 millihenry, 100 kilohertz, and the value of resistance is 2.5 kilo ohm. Okay, so now when you will solve it, you will get an answer 0.6, which Nilmesh is already getting. Very good, Nilmesh. Okay, so this is how you can solve this question. This is a very important thing that you should know. If the converter is operating at the boundary of continuous conduction, I minimum will be 0. At that time, what is the value of D? So D value is 1 minus 2L upon RT. Divya, is this fine with you? Nitya, Divya, is this fine with you? If the converter is operating at the boundary of continuous conduction, the D value for buck converter, not for all the converter, D value for the buck converter will be 1 minus 2L over RT. In this way, you can calculate in boost and buck boost converter as well, and you will get different expressions. Okay, so I hope this is clear to you. Any problem, any confusion that anybody is having? You want to ask anything? Sir, we have to substitute LC, right? Where you have to substitute LC? Divya, where you will be substituting LC? In fact, if suppose the duty ratio would have been given to you and you want to calculate LC, you can calculate LC from this formula as well. Okay, is that clear? Here we have calculated the value of D. Okay, upon RT. L here itself is the critical value because it is giving you an operation on continuous conduction mode, boundary at the boundary of continuous conduction mode. Okay, if suppose D value might be given and we want to calculate L, we can use this formula for calculation of L as well. I hope this is clear. Okay, Divya. Now moving towards the next question. Okay, now see this one. This is a very good question. So in the chopper circuit shown in the figure, again we have which converter? This is buck converter. Okay, buck converter or step down converter. In the chopper circuit shown in the figure, the input DC voltage has a constant value of 220 volt. Okay, the switch S is operated with a switching frequency period of 60 milliseconds. Switching period means we have been given time period, okay, which is 60 milliseconds. So you can calculate the frequency by inversing the time. Okay, then in such a way that the conductor is at the boundary of continuous and discontinuous conduction. Again, we are talking about the boundary of continuous and discontinuous conduction. Continuous conduction is not assured. We are at the boundary. So at boundary, I minimum is, you have to tell here. Okay. Then which of the following is or are correct? MSQ question. They are asking that peak to peak current will be this value, average inductor current will be this value, maximum inductor current will be this value, and minimum inductor current will be this value. Okay, so you have to choose among the option. So your time starts now. Because it is a lengthy question, I have to give you more time. So I am giving you 3 minutes for this. Okay, tell me which one will be the right option. In this question, you have to comment upon 4 quantities. So Nilmesh is saying C and D are the correct option. Okay. In this way, good MSQs can be designed. Okay. And I think DC to DC converter is an ideal choice for an MSQ question. Okay. So the time is over. And what answers? Nilmesh is saying C and D. Very good. So just see. Converter is operating at the boundary of continuous and discontinuous mode. And what has been given to us? Only the value of time period. Okay. We don't know the value of D even. So can you tell me, at the boundary of continuous conduction mode, CCM means continuous conduction mode, what is the value of D? The D value we have just calculated. It is equals to 1 minus 2L upon R into T, isn't it? So we can calculate the value of D right here from this formula. Now what are the different values? 1 minus 2, L value is 100 millihenry. Okay, so into 100 millihenry. What is the value of R? 10 ohm. And time period 60 milliseconds. Okay, so from here you will get immediately the value of D, and that D value is 2 by 3. Okay, that D value will be 2 by 3. So you have calculated the D. So just see how important this formula is. If you have a remembrance of this formula, it will be very useful for you in order to calculate the value of D. Otherwise you will be applying conditions and then you will be calculating. So we calculated the value of D. Now what we have to calculate? Peak to peak current. Peak to peak current means we have to calculate I max, and I max, as you know, is IL average plus delta IL by 2. Okay, and since the converter is operating at the boundary of continuous and discontinuous conduction mode, what will be the shape of inductor current? The shape of inductor current will be like this, isn't it? I minimum is 0. Okay, this will be IL average, and this amount will be what? This amount will be delta IL. And how much will be this amount? This amount will be delta IL by 2. Okay, and one thing we are sure is that I minimum is equals to 0 and IL average is delta IL by 2. So just see, option D, minimum inductor current is 0, is a correct option. Okay, so we got one answer as well. So now can you tell me, IL average, which is delta IL by 2 plus delta IL by 2, will become ultimately what? Delta IL. And delta IL in case of a step down converter is D 1 minus D Vs over F into L, isn't it? So I max will be having this formula. Peak to peak, what we have to calculate here? Peak to peak current, average current and maximum current. All these currents is what we require. So just see, what we have obtained here is this value. I max, which is maximum current, is equals to peak to peak current as well. Okay, peak to peak current means delta IL. Yes, very good, Nilmesh. Which is D 1 minus D Vs over FL. This is what we have concluded. Now put the values. D is 2 by 3. So 1 minus D will be 1 by 3 into, how much is Vs? Vs is 220 volt. 220 volt divided by F. F value will be 1 by time period. So time period is given 60 milliseconds. Okay, 60 into 10 to the power minus 3. That will be the value of F. And L value, how much is the L value? L value is 100 millihenry. Okay, so once you will calculate this, how much will be the answer? I max or delta IL? You will get 29.34. Okay, 29.34 amperes. Is that correct? So Peak to peak current. Peak to peak current means delta IL. Is it 14.67? No, this is wrong. Okay. So this option is a wrong option. Average inductor current. Average inductor current, just see. And maximum inductor current 29.33. Is this correct? Yes, this is correct. Okay. Maximum inductor current is 29.33. Peak to peak current, which is delta IL, is 29.34 as well. It is not 14.34. Okay. Average inductor current. So how much will be the average inductor current? Just see. Average inductor current will be delta IL by 2. And delta IL is 29.34 divided by 2. Okay. So how much you will get? Delta IL, then how much you will get? IL average around 14.67. Okay. So whether IL average is 14.67, average inductor current is not 29.33. It is around 14.67. Okay. So see, this is how you can calculate all the values. Is that clear? Just see. Option number C and D will be the right option. So I think Nilmesh and Divya both have calculated the correct answer. Very good. So just see, continuous conduction mode boundary, if the converter is operating, this is how your inductor current will be behaving, and I minimum will be 0. And if you know this condition for buck converter, this condition you may derive for boost and buck boost as well. Different formulas you will be getting. Through this you can calculate the value of D, and you know that Imax will become, Imax if you will calculate by using this formula, it will become delta IL, which is peak to peak current, and then IL average will be delta IL by 2. In this way you can calculate all the values. Okay. So this is a very good question, an ideal choice for an MSQ type of question, guys. Okay. I hope this is clear to everyone. Now moving towards the next question. Just see this question. The IGBT as shown in the figure is operating at a switching frequency of 30 kilohertz. Just write the data. Switching frequency is 30 kilohertz with a duty ratio of 60%. Duty ratio is 60%, means 0.6. The peak to peak ripple in the source current. Peak to peak ripple in the source current. Peak to peak ripple in the source current means delta IL is what you have to find. And average current through the IGBT. IGBT means switch, so you have to find the average switch current. These are the two quantities you have to calculate. Again, it is an MSQ type of question. Okay. And the converter is a boost converter. Yes or no? It is a boost converter. Whenever you have inductor at the output, converter will be buck converter or step down converter. Whenever you have inductor at the input, converter will be boost converter. And if you have inductor in between both the input and output side, it will be a buck boost converter. This is how you can identify the type of converter. Questions may come on the identification of converter as well. Okay. So your time starts now. This is a very easy question. I hope that you can solve this question. You have to find the peak to peak ripple in the source current delta IL, and you have to calculate the average switch current. Nilmesh answer is B and what, Nilmesh? Last 20 seconds. B and C. Okay. So just see. We have to calculate the peak to peak ripple in the source current. Means peak to peak current, delta IL. Okay. So for boost converter. Or even for buck boost converter, you will be having the same formula for peak to peak current, and the formula is dVs over F into L. This formula is equally applicable for buck boost converter as well. dVs upon FL. Okay. Now through this you can calculate the required values. So whether we have everything, the D value is 0.6. Fine. Vs. How much is Vs? Vs is 200. And do we have frequency? Yes, it is given 30 kilohertz. Do we have the value of L? Yes, it is 10 millihenry. Okay, so from here you will get what? 0.4. So this will be the peak to peak ripple in the source current. Now you have to calculate the switch current. Okay. Now if suppose you don't know the formula of switch current, how you can get the switch current? Just see. Let me draw the inductor current. So this is my inductor current. Across each converter, inductor current has a linear variation like this. Okay. This is the on time and this will be the total time. So this is my inductor current. Now if suppose I want to have the switch current, or if suppose I want to have the diode current as well. Okay. If I want to have the switch current or the diode current. This is my diode current. So just see. Can you tell me in this figure when your switch will be carrying current? Switch will be carrying current when it is on. And when it is on, what current it will be carrying? It will be carrying the same inductor current, isn't it? And when it is off, it will not carry any current. So when your switch is on, it is carrying the same inductor current. So you will make the same inductor current during the on time as your inductor current is, and during the off time it will not carry any current. Okay. So just see, this will be the switch current and this will be the average value of switch current. So just see, average value of switch current. Switch current is present only for the on time. So for the on time, we will write here D. Okay, D indicates the on time only. And this switch current you are deriving from inductor current. So D times the average inductor current. Okay. Similarly, if we see in towards the diode, so when switch is on, diode will be off. When diode is on, it is carrying the same inductor current during the off time, isn't it? So just see, when the switch is on, diode will normally be off. Now diode is carrying the same inductor current during the off period as your inductor current is. So whatever is the shape of inductor current, we will just copy this, and this will be my average diode current. So what will be the magnitude? Average diode current. Since it is present during the off time, so off time might be denoted as 1 minus D, and it is derived from the average inductor current. So we will write it like this. Okay. So this is how you can get the different currents across different devices, switch current or the diode current. Okay. So we have to find here what? We have to find here the value of switch current. Okay. So focus on switch current. So average switch current. Average switch current is D times the average inductor current. Okay. Now what will be the average inductor current here in case of boost converter? Just see here. Whether this source current and this inductor current, they are not the same, isn't it? So whatever is my inductor current is the same my switch source current will be, isn't it? So can I write here that the average inductor current is equals to average source current as well? Okay, and what will be average source current? It will be D times I naught. How to find this? How to write for the source current? So let me tell you a trick. Just see. It will be I naught upon 1 by D. Okay. Let me tell you a trick. This is a boost converter. Okay. In a boost converter, what is the output voltage? It will be equals to Vs upon 1 minus D. Now if you are writing for source current, you will have same 1 upon 1 minus D ratio, and it will be I naught here. So you have to write I naught here, you have to write Is here. So whatever formula you have for linking the input and output voltage, same formula you will be having for linking the source current and output current, but in the reverse manner. This is how you can memorize the expression of source current in all the converters. Okay, for example, in case of buck converter, this will be Is equals to D times I naught. In case of buck boost converter, it will be D upon 1 minus D times I naught. This is how you can remember it. Okay. So just see here. D times IL average, and IL average what we have calculated is I naught upon 1 minus D. So it will be D upon 1 minus D times I naught. Now what is D? D is 0.6 upon 1 minus 0.6. And how much is the I naught? Do we have the value of I naught? No, we don't have the value of I naught. So just see how to calculate I naught. Okay, how to find I naught. So just see, the output voltage here will be what? The output voltage you will get here. Okay, this is a load. For example, this is a DC motor. Okay, so this is the load that we have. So what will be the output voltage? The output voltage will be E plus I naught R, isn't it? From here, what will be your I naught? It will be V naught minus E upon R. And what will be the value of V naught? V naught is, this is the boost converter. So V naught you may get from Vs over 1 minus D minus E over R. Okay, now put the values. What is Vs? 200 upon 1 minus D will be 0.4 minus E is 50 divided by R is how much? 10 ohm. So what will be I naught here? What will be my current I naught here? It will be 45 amperes. Okay, just see. By applying the KVL at the load side, I will get this current. Okay, by applying the KVL at the load side, I will get I naught current. This is how you will determine I naught. Is that clear to you, Divya and Nilmesh? Okay, 45 ampere will be my current. So now again come back here and put the value here, 45. Then how much will be the answer? The answer that you will be getting is 67.5 amperes. So first you have to find the peak to peak ripple in source current, which is 0.4. Switch current, average switch current is 67.5. Okay, so which options are correct? Option number B and option number C. So you are absolutely correct. Divya and Nilmesh, you are absolutely correct. Fantastic. Clear? Any doubt that anybody is having in this question? Tell me. Nitya, Selja, Niharika, Divya, Nilmesh, any doubt that you guys are having here? Very good. Okay, so this is a very good question. Same kind of question you can expect in the upcoming GATE exam. Okay. Now, come back to this question. This is also a very interesting one. A DC to DC boost converter is shown in figure below if the duty ratio for the converter is 0.7, means the value of D is given. And how much the value of D is? 0.7. Conduction time for switch is 285 microsecond. Conduction time means switch on time. It is 285 microsecond. Okay. Then the ratio of maximum to minimum inductor current. Yes, this is the most probable question for the upcoming GATE exam. Ratio of maximum to minimum inductor current. Okay, this is what you have to calculate in this question, and your time starts now. but up till 2 it will be ended, before 10 minutes. So what we have to calculate here is the ratio of Imax to Imin. Okay. Just see what has been given is T on and D, and we don't know the value of T. Okay. So T might be, you know that T on is D times T. So T will be T on divided by D. So T on is 285 microseconds divided by D is 0.7. Okay. So when you will divide it, what value of T you will be getting? T will be 407.14 microseconds. Okay. So it will be 407.14 microsecond. That will be the value of T. Immediately calculate the value of F. So F will be 1 by T. 1 by 407.14 microsecond. Now when you will put this value, you will get the value of F, and that F value will be 2.45 kilohertz. So you can calculate immediately these two things. Okay. Now we require the value of Imax and Imin. For that, what formulas we have to use? Just see. Imax upon Imin. Okay. This is what we have to calculate. So what is the value of Imax and Imin? This will be IL average. Okay. Plus delta IL by 2. That will be Imax. Similarly, IL average minus delta IL by 2, that will be Imin. This is what we have to calculate. Okay. So for that we require the value of IL average. Okay. And IL average across a boost converter is equals to IS average, and that is equals to I naught upon 1 minus D. And what is I naught? I naught is basically V naught upon R 1 minus D. And what is V naught? So ultimately what we can write for it, V naught is Vs over 1 minus D. So in this way your formula will become Vs over 1 minus D square into R. Now if you will put the values, what is the value of Vs? 180. 180 minus 1 minus D is 0.7 square into the value of R is 10 ohm. Okay. So after putting the values, when you will solve it, what you will get as IL average is 200 amperes. Okay. So IL average will be 200 amperes. So we have calculated one answer. Nilmesh is getting an answer 101.09. Very good, Nilmesh. That is correct. Okay. Then we require the value of delta IL. So delta IL in case of boost converter is dVs upon FL. Okay. So what is D? 0.7. Vs is 180. What is F? We have calculated 2.45 kilohertz. So 2.45 kilohertz into what is the value of L? 3 millihenry. Okay, so when you will solve it, you will get the value of delta IL. And how much is delta IL coming? 17.14. So see, we calculated what is required here. Now put the values. What is IL average? 200 plus delta IL 17.14 divided by 2. Similarly, 200 minus 17.14 divided by 2, and you will get 1.0. You will get 1.09, or you can write it approximately equal to 1.1 as answer. Okay. Yes, Divya, that is correct. And final answer will be 1.1 here. Okay. So ratio of Imax to Imin. This is very important. This can be asked for any converter. This question we have done here for boost converter. Be ready for buck converter or buck boost converter. Okay. So just see. This question we have already solved. I hope it is clear to you guys. Now moving towards the next question. Just see this question. Okay. Which is very, very important. A boost converter is feeding a variable resistive load as shown in the figure. If the switching frequency is 100 kilohertz and the duty ratio is 0.6, what is the switching frequency? 100 kilohertz. What is the duty ratio? 0.6. It gives an output voltage of 48 volt. Output voltage is 48 volt from a 12 volt supply. So Vs is how much? 12 volt. The value of R that will make the inductor current just discontinuous. Whenever you are watching this line, that means I minimum is equals to 0. Isn't it? How many times we have seen question like this? I minimum will be 0. So can delta IL is T on Vs upon L. T on Vs upon L. Yes, you can write it. Okay, you can write it. So whenever you are watching this line, current just discontinuous means I minimum is 0. Means we are at critical condition. Okay, we are at the boundary. Whenever we are at the boundary, okay, so I minimum will be 0. What we have to calculate here? The value of R that will make the inductor current just discontinuous. Okay, so whenever we have this condition that I minimum is 0, that means your IL average will become equals to delta IL by 2. Okay, now when you will further solve it, Nilmesh, are you asking anything? Del IL is T on into Vs upon L. Yes, you can write it. D upon F is what? DT. DT means T on into Vs by L. You can write it. Okay. Now, when you will apply this condition, you will get the value of critical inductance. And that critical inductance, what converter we have? We have this as boost converter. So in case of boost converter, the value of critical inductance is D 1 minus D square R by 2F. Okay. One way possible is that you can memorize the formula of LC for each converter. The other way is that you remember this condition. This is the condition of getting the value of LC. Okay. If you remember this condition of getting LC, you can get the expression for LC. Now, from here, what will be the value of R? Okay, just see, everything is given. LC, we may use the given value, 100 microhenry. The value of D is 0.6. 1 minus D will be 0.4. The value of R we need to calculate, 0.4 square, into 2 into F, 100 kilohertz. Okay, so R is the only unknown here. When you will solve it for R, what answer you are getting? 208.3. Okay, when you will solve it for R, you will be getting 208.3 ohm as answer. And using that formula, IL is coming out to be different. How it can be different? D upon F. Nilmesh, T upon F. Just see, T on is equals to what? D times T. Okay, or you can write it D upon F. Okay, T on will be D upon F. So D upon F might be written as T on. So T on might be written as D upon F. So is this correct? T on is dt. So T will be T on by D. This is correct now. there will be any calculation mistake, Nilmesh? I don't think you are getting a different answer. This is correct, okay? Maybe either me or you have done any calculation mistake, unless this is absolutely okay. D by F might be written as T on, isn't it? 1 by F is T. D into T is T on. Okay? D into T is T on. There might be any calculation mistake that may be either done by me or you. Unless this is absolutely correct, you can apply, go for it, okay? So focus on this question. So through the formula of LC, we can get the value of resistance here. Is that question clear to everyone? Okay. So these expressions of critical inductance are very important for us. If you are able to memorize, that's absolutely fine. If you are not able to memorize, you can immediately get. It will only take 30 seconds of yours. This condition you have to apply for each and every converter and put the respective value of IL average and delta IL. You will get the value of LC. And through that, in this question, we can get the value of R as well. Okay. So I hope this is clear to everyone. Now moving towards the next question, this question. This is a very, very good question. Okay. Anytime this can be a part of GATE exam. So this is a very, very good question. What has been given is, in the figure shown below, the switch is operated at a frequency of 30 kilohertz. So you have the value of frequency, 30 kilohertz. Okay. With a duty ratio of 0.55. So the duty ratio is 0.55. If the power absorbed by the load, so the load power is given. Load power is V0 into I0 and this is given to you 30-100 watts. Okay. Then average value of inductor current will be, you have to find what will be the average inductor current here. Okay. You have to find in this question what will be the average inductor current. What type of converter we are having? Can you tell me? Looking into the position of inductor, it is not present totally on the output side. So it is not a buck converter. It is not present totally on the input side. So it is not a boost converter. It is in middle of both the sides. So it will be a buck boost converter. Okay. So the converter that you have is a buck boost converter. So for the buck boost converter, if you have to find average inductor current, this will be equals to what? I0 upon 1 minus D. Isn't it? Whether it is boost converter or buck boost converter, average inductor current is I0 upon 1 minus D. For the buck converter, it will be only I0. Okay. So this has become a very popular expression. We frequently are using this particular expression. So I hope you are able to memorize. So in order to calculate this average inductor current, what do we need? We need the value of D and I0. D is given. I0 we can calculate through this formula. So what will be I0? I0 will be P0 upon V0. Okay. P0 upon V0. So P0 is 200, but we don't know the value of V0. So for buck boost converter, what is the value of V0? It is dVs over 1 minus D. Isn't it? So now you can put the values. 3200 upon, what is D? 0.55. So 0.55 into Vs is 100 upon 1 minus 0.55. When you will solve it finally, you will get an I0 value of 26.80 amperes. Okay, and when you have this value, come back here and put the values here as well. Okay, and when you will do the things, what answer you will be expecting here? IL average will be 58.18. Okay, I hope you all are getting the same answer. Very good. Nilmesh says lightning fast. Very good. Good speed, Nilmesh. An excellent response from your side as well, Divya. Okay, keep on these efforts. So I think this question is clear to everyone. Okay, in fact, this is a very good question. Power is given and you have to return, you have to calculate back the average inductor current. So this makes this question a very popular one. This may be the part of your GATE exam. Okay. Now after that, yes, this is also a very, very important question and this should come in the GATE exam. What is given here in this question is, a DC to DC converter is used in regenerative braking mode of a DC series motor. As shown in figure, it is operating on a duty cycle of 65%. Duty cycle is 65%, means 0.65. Average value of armature current is, this is your armature, okay, and the motor you are using in regenerative mode, so power is getting feedback to the source. So average armature current is basically the average load current given to you, which is 110 ampere. It is continuous and ripple free, so we can assume the constant operation, okay, ripple free current. The power feedback to the supply will be, what will be the power feedback to the supply? You have to calculate V0 into I0, okay. What will be this value? Okay, power feedback to the supply is what you have to calculate. So you are using your motor in regenerative braking mode, okay. Which mode? You are using your motor in regenerative braking mode. Regenerative braking mode means motor is feeding power to the source, okay. So current will be flowing from motor towards the source. So when it will be moving from motor to the source, your inductor will initially charge and switch will be on, okay. Let me mark this to be the output voltage, okay. Let me mark this to be the output voltage. So if this is the output voltage, when motor is feeding power to the load, let us suppose that you have switch, your switch is on. So at that time, what will be the inductor polarity? This will be plus, this will be minus, and inductor current will be flowing in this direction, isn't it? So when your switch is on, at that time, what will be the output voltage that you will be getting? Is 0, isn't it? Aryan Agarwal, he has calculated and is saying 22.33. Very good. Very good, Aryan. Excellent. If you are able to solve this question, you are well prepared. Now, when you will turn off the switch, when your switch will be off, okay, at that time what will happen? So when the switch is on, this is the inductor polarity at the beginning, and at the end the inductor polarity will be like this, okay, at the end. So due to this inductor polarity, this diode will get on. When this diode will get on, your circuit is completed in this manner, and that moment your output voltage will be equals to Vs, isn't it? So if I just plot this output voltage which we are getting is, just see here, we are getting something like this. For the on time, and we have the off time as well. So for the on time, what do we have? For the on time, we are getting 0 voltage. For the off time, we are getting Vs voltage, isn't it? Just see. For the off time, we are getting 0 voltage. For the off time, we are getting Vs voltage. So if I ask you what will be the average output voltage, your answer will be, it will be Vs into T off divided by T, or you can simply write 1 minus D times Vs. Isn't it? Isn't it? Very good, Nilmesh. Your answer is also correct. So whether this is understood to everyone, those who are not able to write it or calculate it, okay? This motor is driving this circuit. Regenerative mode we are using, okay? So this is how the power flow will be, and this is accordingly how the switch is getting on and off, and of what transition the output voltage will be making. We have just plotted that, and based on that we have calculated what will be the value of output average voltage, okay? Now, yes, it is a kind of boost converter, okay, Nilmesh? Now 1 minus D, D is 0.65, okay? And what is the value of Vs? It is 580 volt. So how much average output voltage we will get? It is around 203 volt, okay? Then if we have to calculate the power feedback means P, it will be V naught into I naught. Okay. So how you will calculate the power now? So power P naught will be V naught into I naught, that is 203 into 110, or you will get 22 point, how much you are getting? 33 in terms of kilowatt. Okay. So in terms of kilowatt we have to answer. This is what you will get. Okay. Yes, Nilmesh, you can apply that condition as well. VSIS equals to EBI naught. Yes. Okay. So just see, this is how you can solve questions like this. If gate authority has to do something exceptional, something new, something extra, if they want you to puzzle, they will give you this kind of question. And if you are able to solve these questions as well, you are well prepared. Okay. So very good. Nilmesh, Aryan, Divya, very good. Divya, is that understood to you as well? Very good. Okay. Now, moving towards the next question. Yes, this question. Just see this question. Now, these type of questions have been the part of GATE exam long back in the year 2018. And since then, the GATE authorities, they haven't asked a question like this. So, be ready. This can be the part of the upcoming GATE exam as well. Okay. Yes, electric drive question. So, what has been given in this question is, which of the following statements is or are correct for the circuit shown below? So, this is the circuit given to us. If you see this circuit, this is a kind of what circuit? This is a kind of buck converter we have. Okay. And if you see further, we have connected two such converters in parallel. Okay. So what do we have here? Two buck converters in parallel. Okay. Two buck converters are operating in parallel. We can call it interleaved converter. Divya, you understood the last question? This is called as interleaved converter. Okay. So, which of the following statements are true? The switches are operated 180 degree out of phase. Yes, this is correct. If you see, there are two converters which are identical to each other. Okay. So, what will happen? Normally, why do we do this? Is just because of this. Normally, this option is correct. The switches are operated 180 degree phase shifted. Okay, the phase shift is given by this amount. The phase shift is 360 divided by n, where n is number of converters. Okay, number of converters. So how many number of converters we have here? 2. So phase shift will be 360 by 2. Okay, so that is correct. 360 by 2 equals to 180 degree. And why we are having this phase shift? We will be operating this converter one after another. So if suppose one current is decreasing, suppose I am drawing the variation of inductor current 1 and 2 respectively. Okay. So if suppose this is my inductor current 1, increasing, decreasing, increasing, decreasing. What is this? This is my inductor current 1. Then I will be operating the second converter in such a way that inductor current will be first decreasing, then increasing, then decreasing, then increasing. Just reverse of the first one. Okay. So how much ripple we have right now? This much ripple. But if I operate, yes, so individual ripple is del IL. But if I am operating them parallel, the sum of these two currents, okay, will be like this. Will be having a variation like this. The sum of these two currents will be having a variation like this. Okay. So what you can see? This is now delta IL dash. Okay. What is this? This is a sum of current IL1 plus IL2, total inductor current, which you will be getting here. So what is the current here? IL is basically IL1 plus IL2. Okay. So sum of current will have a ripple of delta IL dash, and it is clearly visible here that the delta IL dash is very less than delta IL. Okay, so filter requirement L and C values will be very low because you have reduced the ripples, so filter required to reduce to minimize the ripple will be very less. Okay, so just see, individual converters will carry more ripples, but the combination will carry less ripples. Now answer these questions. First one is, the switches are operated 180 degree out of phase. You have the formula of phase shift. If suppose 4 converters are there, phase shift will be 90. So that is absolutely correct. B is, the switches are operated in phase with each other. No, then the purpose will not be solved. Okay, they are always operated phase shifted. You can see if one current is increasing, other is decreasing. Inductor currents are 180 degree out of phase with respect to each other. That's what we are talking about. Absolutely correct. D is, each inductor supplies one half of the load current and output power. Yes, together they will carry more power. Okay, so D is also correct. Okay, D is also correct. So this is a very good question. Okay, from interleaved converter. You may connect to boost converter or buck boost converter in parallel as well. Okay, so is that question clear to everyone? Any doubt that you people are having? I don't think so, because you have answered this correctly. Very good. Now just see this question. This is a very good question. The figure shows 2 buck converters connected in parallel. Okay, so we have same interleaved converter. The common input DC voltage is 200 volt. So we have been given the input voltage. Input voltage is 200 volt. The converters have identical inductor value. The load resistance is 8 ohm. How much is the value of load resistance? This is 8 ohm. Both converters are operating in continuous conduction mode with negligible ripple. Each converter carries a source current of 8 ampere. So just see, each converter is carrying a source current of 8 ampere. IS1 and IS2 are 8 amperes. So can you tell me how much will be IS? It will be 16 ampere, isn't it? Because IS is IS1 plus IS2. So it will be 16 ampere. When they are turned on, one after another, the duty ratio of each converter and current supplied by the source. So current supplied by the source is 16 ampere that you have calculated. Now you have to calculate what will be the duty ratio. Okay. So you have the value of source current right now, which is 16 ampere. Now you have to calculate the value of duty ratio. So you know that source current is equals to D times I naught. Okay. Or I naught you can write V naught by R. Or V naught you can write dVs, so it will become d square Vs over R. Okay. So from here what will be the value of d? It will be R into Is upon Vs in square root. So just put the values. What is the value of R? 8. Source current 16. Vs is 100. 200 square. Sorry, 200 only. Okay. So by putting the values, Nilmes is getting an answer 0.8. Whether 0.8 is the correct answer? Yes, 0.8 is the correct answer. Okay, so you can calculate that 0.8 is also a correct answer. So last 3 questions that we have discussed they are ready to be a part of GATE exam. Are you ready for this kind of question? Make yourself ready. Okay, this is how you could have approached for this particular question. Okay, so what expression we have obtained for D? The expression for D is R into Is upon Vs. Just see, through this expression we have calculated the value of D. Okay, so last 3 questions are very important for any GATE aspirant. Okay, so did you like this session, guys? This is the end of the session. All these questions I wanted to discuss with you, and we have discussed those questions. So if you'll practice enough all these questions, you are well prepared for the GATE exam. So I hope you have liked this session. Okay, now if you want to experience the same teaching and learning experience, if you want to have, join IMS GATE Academy. So right after this session, you will get the PDF of this session on our Telegram channel. You can join our Telegram channel through this link, or the description is also given in the description box, okay, or the link is given in the description box. Through that you can join our Telegram channels to get further updates or the PDF of the sessions, okay. Aryan, especially I'm talking about you, you can get all those PDFs of particular sessions, information about GATE exam and other PSUs in our Telegram channel, and you will get a daily quiz activity as well. And if you wish to join us, we are offering fantastic courses here, okay. So the course will contain around 700 to 800 hours of live classes with excellent theory book, exercise book and GATE question bank, okay. Hello Ronit. And apart from that, we will be offering you 12 personalized sessions in which you can personally discuss your preparation strategy, your doubts, and 130 online test series that consist of 3000 questions. So if you are able to practice 4,000 questions of exercise book and 3000 questions of test series, so if you are prepared with these 7000 questions, you can crack any exam of the world, okay. So this is what we are offering you. So if you are really impressed what we have covered in the class, you can call on these numbers to book a free counseling session, okay. So join us and have flavor of what we are offering to our student, okay. Same experience you can also have. Last but not the least guys, tomorrow again we will be coming live at 5 PM, okay. Do not forget the time, at 5 PM, and tomorrow we will be discussing questions related to inverters and rectifiers, okay. So how was the session today? I hope you all have enjoyed. We have discussed some fantastic questions here, okay. Especially the last 3 questions, they are ready to be a part of GATE exam, but whether you are ready or not, that you have to think, okay. But the students present right here in this session, they are very well ready for the upcoming GATE exam and these kinds of questions. So you people have answered almost all the questions correctly, okay. So you are in great touch of this preparation, you are in great touch of preparation. So keep on preparing well, okay. Revise as many times as you can and also appear in the mock test to get an exact flavor what you have prepared right now and what the GATE exam is demanding from your side, okay. So I hope this session was a fantastic one and you people have really liked this session. Is it so? Ronit, Nilmesh, Divya, you enjoyed this session? Okay. So thank you so much for attending the session. We will meet tomorrow at 5 PM and we will discuss rectifiers and inverters, okay. So share this session with your friends as well and subscribe our channel to get more updates related to your GATE preparation. Thank you so much.